Let's look at one last example of a paired T interval. This one is called glaucoma in dogs, and glaucoma is an eye disease that causes high eye pressure and can be really dangerous. So we have two drugs, drug A and drug B, that are used for the treatment of glaucoma, and they're tested on 7 dogs. So what they did is for each dog, they randomly selected one eye to get drug A, and then the other eye got drug B. 1 hour later, they took pressure measurements of both eyeballs, and then they recorded that information in the data sets. You can assume that the pressure measurements are normally distributed, and our order of subtraction here is drug B minus drug A. So you have a couple of questions to work on. First, you want to answer, why is this paired or dependent data? So why are we using that paired T process? Then you're going to find a 90% confidence interval for the mean difference in the pressure readings. And then based on the interval you find, you want to answer the question, is it possible that both medications work the same? You want to give a brief explanation why or why not. So go ahead and pause the video and give this a try. All right, so the first question you were working on is, why is this paired or dependent data? Okay, and the answer to that, there's kind of a couple ways we can work through this. The first one is that for each dog, we have 2 measurements recorded. So we have the eye pressure from the eye that got drug A, and then the pressure from the eye that got drug B. So we do have 2 pieces of information or data for each of our subjects. And then it's pretty fair to assume that those eyeballs on the dogs are going to be really similar. So if instead we'd done this dog only gets drug A and a different dog gets drug B, then we wouldn't be able to do this process. But because we use the same dog with both of the medications, we just did one eye with one and one with the other, we can get away with this paired T process, and we'll get some better information because those eyes really should genetically be fairly similar on that same dog. All right, our 90% confidence interval. So P is a 90% CI for the mean difference in pressure readings between the 2 eyes. Okay, the A is our assumptions and conditions. So we're doing drug B minus drug A. And so we don't have a simple random sample. That's not stated in the problem, but it does say that we can assume the differences are normally distributed. So we have that stated. And then our sample standard deviation is 0.03. That makes us a paired T interval. And the endpoints I got are negative 0.05 to negative 0.008. So both of these are negative. And my conclusion statement is we are 90% confident the true mean difference in pressure readings between the 2 eyes and medication is somewhere between negative 0.05 and negative 0.008. And then our last question was, is it possible that both of these medications work really similarly? So in order for that to be true, we would need to have the number 0 in the interval, meaning that there's no difference in the eye pressure between drug A and drug B. 0 is not in our interval, and so that means we can exclude that as a likely possibility. Okay, and in fact, with that negative interval, what we're really seeing is that drug B dropped the eye pressure more than drug A. Okay, so drug B would probably be the one you would want to use if you were a veterinarian. All right, so that is our paired T interval. So chapter 21, we looked at the 2 independent samples with the 2 sample T test, and then we wrapped it up with this paired T interval for our dependent or our samples that go together.